How to use the MATLAB robot simulator. First, enter N, then then there are brackets provided as space for the twists. Then enter the twists in this text space. Then after that, enter the initial XYZ configuration, XYZ positions, separated by semicolons. Enter the resolution. In this case, this is 24. This means all the angles between 0 and 2 pi. There are 24 different angles between 0 and 2 pi that each joint will be able to be set to during the simulation. And then click draw. And after you click draw, the robot will be drawn to the initial configuration. And then the status bar will say sampling manipulator positions, meaning it's going for all those 24 positions and finding all the points the robots can reach. After that is done, it will say done. And then in this panel called the Cartesian editor, the user can enter a specific position they want the robot to move to, and then click move, and the robot will move to that position. And that is happening now. The animation is done at 60 frames per second, and for any given position, for moving from any given position to another, the robot moves into that position in 100 steps. Okay, so another position is chosen. So this is the final position, and there are all the joints, and this shows that the lengths are preserved for also all the joints of the robot. If I enter -1 in the z-axis, for the point, the robot will move from the original position and shift to the next position. And this is the next position. The final position is so it goes to the approximate position to the final position. If you can't fully reach that position based on this, the division of the angles. But there is another example of the position the robot may be able to reach. So it moves to 0, -2, and 1 from that position. And the final coordinates are shown in the status, which is very close to 0, -2, and 1 as specified by the user. And you can also check using the cursor, and we can rotate the graph to see where the final position is. Using the toolbox, look at it up here, and you can check each length as well. Each joint position as well. Okay, so I will try 201. We check with the cursor where the robot has moved. And so x coordinate 2, 0, 1. 0, 1. This is the final position. Make a triangle. 101. And this is the final position. So this is how the robot manipulator works. To enter a different robot, use the same steps. Start with an N of 3 or N of 4. It clears a space, and then inside these spaces all the twists can be entered, separated by semicolon. Each point in the twist will be separated by a semicolon. Then the initial XYZ position will be entered, and then click draw. Reset clears the fields, so you can start writing unit twist for robots again. Thank you, and have a great summer.